Hello everyone. We are now demonstrating the interlaminar fracture toughness test on unidirectional carbon fiber reinforced composite material in tensile mode, also called Mode 1. This test is conducted according to the ASTM D5528 standard that uses a double cantilever beam specimen to measure the crack propagation caused by an opening load on one end of the specimen while synchronously recording the load, opening displacement, and the delamination length. The standard describes two methods of holding the specimen, bonding with a hinge or a block. But both methods involve multiple steps and take time to prepare. This is the test fixture for specimen bonded with hinges. This is the test fixture for specimen bonded with blocks. We have developed a third method to simplify the preparation, which is the direct clamping method, eliminating the time-consuming tedious steps of surface polishing, adhesive bonding, and curing. Here is the specimen made according to the ASTM D5528 standard. We can see that in the midplane of the sample, there is a non-adhesive film serving as the initiator of delamination. Measure the dimensions and mark both edges as required by the standard. Let's install the specimen. Loosen the locking bolt of the upper clamp. Align the side of the sample with the side of the clamping body, making sure that the end face of the sample and the end face of the clamping body are flush. Then tighten the bolt. Attach the upper fixture with the sample onto the testing machine. Slowly lower the crosshead to within the reach of the lower clamping jaw. Tighten the locking bolt to clamp the lower part of the specimen. Now the sample installation is completed. The automatic crack measurement system is equipped with dual lenses that can record the crack lengths on both sides of the specimen in real time during the testing process. The standard stipulates that after the initial pre-crack loading and unloading cycle, if the difference between the delamination positions on both sides exceeds 2 mm, it indicates loading is asymmetric and the specimen either needs to be reinstalled or replaced. The dual lens system, by measuring cracks on both sides, does a better job to ensure test validity and data accuracy than a traditional single camera system. Turn on the strip light sources for each camera. Align the positions of the two cameras on both sides. Adjust the camera focus based on the real-time image on the screen till the image is in the clearest state. Now the test preparation is finished. We are ready to start the test. Select the pre-programmed test method ASTM D5528 in the software and set the test speed to 1 mm per minute. Let's quickly go over the test procedure per the standard. First, pre-crack. When the initial crack length reaches between 3 to 5 mm, the specimen shall be unloaded to zero at a speed of 25 mm per minute. Here we set the crack length of the initial unloading point to 5 mm. After the pre-crack, the test resumes at a speed of 1 mm per minute until the crack length reaches 35 mm. Then, unload the specimen to zero at speed of 25 mm per minute to complete the test. Input the sample dimensions and click Run to start the test. We can see the crack length, as well as the corresponding load and the opening displacement in real time on the screen. The test is completed. The software automatically marks the characteristic points as required by the standard. Crack lengths are automatically filled in, and the toughness value of each point is calculated. Export the test report and save the data by the sample ID.